This conference will now be recorded.
All right. So today we have two topics for conversation. One is from UFI Space team, right, around open aggregation router spec. So we've got K and I think maybe K.
Yeah,
So
this is
walk us through.
correct. Yeah, this is Kai from UV Space. Correct.
Oh, Kai, sorry, Kai.
No problem.
Apologies. And also the other topic we have is from Lauren. We've been trying to schedule that for some time to try to give us a glimpse on, how cruise lines and satellite communications work, right? And if there are areas for us to explore in that. So those are the two topics. With that, Kai, do you want to
Yeah. Uh,
take over the
right.
ball? Are you presenter? Let me just see. Make presenter
Yeah, I'm the
available.
presenter, but if you can grant me the presenter right,
Yeah,
I
that's what
can.
I'm doing. Yeah.
Okay,
Okay. I just did. Yeah. Mhm.
got it.
While you're bringing up, Lauren, any other topics we wanted to cover today, or anybody else for today we wanted to have a conversation about? Craig?
Um, I think I just want to note that we're going to be changing. I think we're going to be changing tools for the monthly meetings. OCP is moving from um, GoToMeeting to Zoom, and so make
Yeah.
sure you look for updates on invitations to make sure you get to the right tool for conferencing over the next month or so. I think everybody's going to be making that change.
Okay. Cool. Craig, anything from you? Or I see also John joined as well.
Yeah, no, just you know, working for those who are have presentations, to be sure to follow the emails that have come out and to get your presentations in order for the global summit that's coming up. And for those who aren't presenting, but be sure to, I believe registration is now open. I know things like if you're not local and you're having to get a hotel, those tend to go fairly quickly. So you may want to get that reservation in as soon as possible. And I did notice that Rob joined. Rob, do you have anything you'd like to comment on from the foundation? Any kind of announcements or anything you'd like to make?
I didn't have any prepared announcements from my side. Thanks, Lauren.
Okay.
Okay. Cool. Why don't we get started? Kai, looks like you've got the ball. I see
Yeah.
the opening slide of yours, so please take it away. I think
Okay.
probably we can keep it to, if we can keep it to 30 minutes, 25 minutes, then we can give the next presenter a chance also to
Sure.
do that one.
Sure. No. Yeah. No problem. I'll keep it within 20 to 25 minutes, and then give a little bit time for any Q&A if there's any. Thank you all. Good morning. This is Kylie with UV Space here in San Jose, California. And also just a quick introduction. Joining me today or this evening in Taiwan is Will Chen. He's from our technical marketing, who he and I been working behind the scene to prepare the presentation for OCP today. So thank you, Will, joining from Taiwan, 1 a.m. midnight. All right, great. So we are actually presenting three platforms from our portfolio today, and we are seeking for OCP Inspire status. And these three platforms are being positioned as the aggregation layer. And then they all are sharing the same data plane from the Broadcom DNX family using the Kurman 2C off-the-shelf merchant silicon. The design broken down into different form factor, port density, use case, things like that. So I'm going to walk through every single one, plus sharing the design block diagram with the audience and a few other use cases on how these things actually are being applied in a real life environment in a telco space and also in a data center space. So that is the topic today with the disaggregation router using the off-the-shelf Broadcom merchant silicon from the Kurman 2C DNX family. All right, without further ado, I'd like to kind of give the audience a big picture from the background. We divided the diagram on the top and the bottom. We put a label 1 and 2. Basically, on the top, we are trying to share the different topology versus the number 2 on the bottom. We are showing the actual use case. So allow me to start with the top on the first. We subdivide that into three different what we call the reference architecture. Certainly, we can use a disaggregation. We can use a open aggregation router as a standalone, connecting directly from the access into the core. Very simple design, inexpensive, but there's no redundancy or load sharing or anything like that. But that still works. But that move us into from the left into the middle, which is the cluster. Let me change my laser pointer so I can follow along. So we can go from a standalone into a cluster, and now we are adding some redundancy and also load balancing from the same axis into the core as compared to the simple one from a topology perspective. And from that, we can also build some scalability on top, not just for the redundancy, but now for the scalability. And by using the good old spine and leaf, a two-tier architecture, using the same merchant silicon box that we built with the different port density and port speed. And now we can have a spine layer and also the leaf layer. And now we are allowing the entire design to scale horizontally and not only we making this with redundancy, but now with scalability. So that's how they evolving from the simple to the redundancy, and now with the redundancy and the scalability. So that's the topology concept. Then on the bottom, we start like putting a real use case. What we are showing is a typical aggregation use case in the middle, where we, in this case, homing some of the residential connection using OLT and ONT through the aggregation layer and then into the core, into the central office. That's kind of the middle one that we highlight with a little blue color. So from the conceptual topology into a use case, and in this particular case, we happen to use a residential design of how these boxes are being put together in the middle. Now, to take it to the next level with this diagram, from the use case of what we saw, and now we actually plugging in some of the hardware that we are sharing with the audience today. In the previous slide, we basically reference to the top, which is the residential services. Sometimes it's known as the SOHO, the small office and the home office. On the bottom on this diagram, we are also adding to some of the cellular carrier type of use case, homing some of the cell site devices from the remote using the same infrastructure of the aggregation back into the application layer and then eventually into the core of the network. So, and now on this diagram, we start like connecting the rubber meets the road with all the different boxes. In our case, our S9600 family are the aggregation layer, and then we have the different model, the 32, the 64, and also the 72. They are just basically the different use case using the same merchant silicon, but different port speed and different port density. So I'm going to get into all the details as we go along. But for now, I just want to spend a couple of minutes to share with the audience the bigger use case, the bigger picture, along with the reference architecture, how this thing is what we kind of call the one-size-fits-all aggregation design to home in all the residential services as well as all the remote cellular services using the same merchant silicon hardware into the infrastructure of the application network to the provider edge, eventually to the core. So the magic that we are sharing today is right in the middle between the endpoint, the access on the residential, the cellular, all the way into the aggregation. So that's kind of the high-level summary. Now, to be compliant with the OCP tenet,
Hey,
we are,
Kai, I have a question.
yes, sir.
When you showed the first slide, you showed going from a single box to the cluster to the spine and leaf. So where in the next drawing where you have the different residential, enterprise, and cellular, in each of those cases, could that be a cluster or a spine and leaf, depending on how many access? So each of those is actually maybe not just a box, but one of either the standalone, the cluster, or the spline and leaf,
All right.
depending on which.
Yeah, thanks for bringing that up. We actually have a slide to address that, but let me answer the question right at this moment. Yeah, thank you for the question. It's exactly what you said, that each one of the use case, like the residential, the enterprise, and also the cellular, these boxes can be is individual cluster for redundancy. But more importantly, we actually recommend our customer to have the separate cluster for the cellular, for the residential, and the enterprise, not only just for the scalability and redundancy we talk about, but also for one more very important reason that we were about to address. And that reason is called the separation of service. So for example, if I'm a carrier, I'm providing cellular services to all your mobile phone using the application layer into the central office. I'm also a carrier providing you fiber to your residential using a separate aggregation cluster to go into the core backbone. I don't want to explain to my customer because I need to bring down on the mobile side to do maintenance, and I have to impact the residential service, and that is called the separation of service concept. So for that reason, we also recommend this to be a separate cluster for the reason. So to sum it up, 3 key points to have a separate cluster for the different residential, enterprise, cellular application. And those 3 reasons are the redundancy, scalability, and also the separation of service for network operation and maintenance.
Thank you.
Thank you. All right, so to be compliant with the OCP tenet and all the principle, so I'd like to spend maybe the next few minutes to kind of address all these topics from the OCP compliance perspective. Allow me to start with the second one first, efficiency, because that actually we consider is the core of the conversation. From an efficiency point of view, these are all leveraging the merchant silicon off-the-shelf kind of component to make these to be very efficient to develop. And then we leverage what is available, and not to mention a lot of the merchant silicon solution today are quite powerful as compared to some of the older day of the ASIC that vendor specific. And on top, we are making this thing quite efficient by making optional TCAM table. These are the content adjustable memory. And later on, we're going to share a couple diagrams for some of the applications that are connecting closer to the endpoint, like the Soho router. We are giving the option to have the additional TCAM memory, so we can have more higher number of access control lists, that kind of thing, to safeguard the traffic, either for traffic control or for carriers billing purpose, like if they want to subdivide to gold, silver, bronze type of user, depends on how much money you pay monthly. The TCAM, the ACL access control list can do all the magic. And last but not the least, these boxes, even though they are designed for the aggregation, we are equipping them with all the timing PTP control with the boundary clock, transparent clock, and also the grandmaster. These are very standard PTP feature, the IEEE 1588 version 2 that are utilized in a lot of the telco environment. So those are from the efficient perspective. And now I can address that with the openness. On top of the merchant silicon that we talk about off the shelf, not to have any close-end vendor-specific ASIC, and these are more the off-the-shelf merchant silicon. And on top of that, we are also adapting to the open network Linux, as well as the Omni, that is the open network install environment. We are following all these different open standard that is available in the community today. And as part of the open ecosystem, when we build hardware based on merchant silicon, we are partnering with a large number of the open source NOS vendor. So this thing is kind of like a plug and play, that the hardware can work with different vendors, NOS network operating system. So kind of to keep the principle and the concept of being the openness, from a hardware, from the network operating system and also from the ONI, the open network install environment, etc. So, and from that together, the efficiency and the openness that kind of make an impact. And then we've been talking about carrier in the last 10, 15 minutes. And due to the flexibility of the ecosystem, we partner with the different NOS vendor. These platforms are not only just for the carrier, but we can also position this in a large-scale data center. Depends on the NOS feature set, the network operating system feature set. For example, like the VXLAN, like the VTAP, the tunnel and termination endpoint, things like that, into the NOS, and we can adapt the same hardware technology into a large-scale data center. And last but not the least, with the scale, the scalability and the sustainability, these things are equipped with the remote management support, meaning that we can do 100% remote upgrade. And then we talk a little bit about the leveraging the spine, same hardware, but spine leaf architecture to make this thing a lot more scalable, either in the telco or in the data center. And then from that, from a
Question,
sustainable, yes, sir.
regarding remote management, what standard or interface are you using to do that?
A lot of the remote management are being focusing on the remote upgrade. So we have this thing that we developed in-house. We call the MU, is called the multiple updater. So we provide a tool to our customer if they want to upgrade the BIOS or things in that nature. Then our tool can actually upgrade all those remote BIOS. Let's say we have a new firmware that we came up, that ties into the BIOS, the different firmware version, things like that. So those tools that we develop, that we provide to the customer, what we call the MU, the multiple updater, and that allow us to do the remote management 100%.
So that's a proprietary tool.
That is a tool that we develop. We partner with some of our large end customer to try to make it open, but that tool originally came out from us, correct? But we actually share that with other folks, and maybe someday we present at OCP to make it more open.
We have to be very clear when we say whether it's proprietary, whether it's open. If it's open, it's on a repository, right? Just because you share it with people doesn't make it open.
Yeah, okay, using your definition, perhaps, yeah.
Okay, so second is that OCP has a desire in the direction to use Redfish manageability. And so that actually is part of the OCP inspired requirements. And I'm trying to figure out whether you meet that.
Yes, both Redfish and also the open BIOS, we are actually in the process of moving to the direction. Thanks for bringing that up.
So are you moving toward that direction, or is this a contribution supporting?
We are moving to the direction, not on this contribution today. We are moving to that direction.
Okay, so you don't see an issue with the requirement for OCP to have a Redfish interface when your contribution doesn't support it?
We are moving to the direction, but to meet the schedule today, we want to bring to the table what we have today. But to answer your question, yes, Redfish, open BIOS, and all this, we are moving to that direction.
Okay, thank you.
Thank you. All right. And last but not the least, just to sum it up on this sustainability, the whole idea of doing all these things, we talk about the timing, the scalability, but one last thing we also want to talk about is to reduce the space, power, and cooling, and that apply in most of the environment in the data center and the central office as well. All right, so for the remaining 7 minutes, I'd like to kind of go into the box and kind of share a little bit of deep dive with the audience. As mentioned before, we are bringing 3 different platforms from a different scalability to talk about the same merchant silicon. And they are all based on the broadband Kurman 2C merchant silicon design. And this is a 16 nanometer technology, fairly advanced from the Broadcom DNX family. And so you are looking at the first one, which the 32X is designed with the concept to support a medium scalability of 100 gig. We support up to 32 100 gig using QSFP 28. And then also this box basically came with 4 different processors. And pretty quick, let me highlight them. We have the data plane, which is the Kurman 2C, the control plane, and that is the Intel processor where the NOS software will be running. And then we also have the BMC, the aspect processor to take care of all the housekeeping and health check, things like that. And the last processor is our timing module that I talked a little bit earlier that support the timing of the IEEE 1588 version 2. So this is a 32 port of the design. And later on, I'm going to show you a dual design that double the density to the 64 of the same version where we are opening up the face panel on the right hand side. To kind of follow the flow, this is the block diagram of the box I just showed you when we open the box. And the 4 processor I talk about, we color code them. The blue one, the BMC 88820, that is the Kurman 2C as the data plane. And then the control plane is on the left upper corner, the Intel Skylake. And then the BMC AST 2400 processor doing all the housekeeping. And then last but not the least is our timing module on the green side, and that is based on the microchip, micro-SIMI type of processing. And we also add FPGA programming on top to make sure that all the timing signal, the data format are being converted back into the format the Broadcom chip can understand. Now, we just went from a 32x to a 64x. And basically, if I just kind of, flashback, this is a 32x. And now we are jumping to a double density. So we actually went from 32 to 64 times 100 gig of QSFP28. And the design is still continue to be non-blocking. And the way we do it is to use 2 processors. This is a dual Kurman 2C design versus the other one is a single Kurman 2C. So everything pretty much stays the same from a timing, housekeeping, BMC, and all that. If you take a look at the block diagram, the only thing changed now, we have 2 Kurman 2C on this block diagram, and we doubled the 100 gig port from 32 port to 64. The control plane, the BMC, the timing, they stay exactly the same. But basically, we double the size of the 100 gig port from a scalability perspective. And then last but not the least, this is the last one we like to share today. This is called the Model 72XC. It's a single Kurman 2C design. And this one is no longer target 100 gig, but rather focus on the high density of the 64 times the 25 gig port. So this one comes with 64 port that support 1/10/25. Now, why are we building different boxes using the same merchant silicon? And it's because there's still a lot of legacy ONT, OLT type of connection, or even some of the cellular connection from the tower are still leveraging a 25 gig. And then some of the OLT, ONT to the residential depends on which part of the United States we are in, or some or different part of the country. And these still using 1 gig or 10 gig. So that's why instead of using 100 gig with the breakout cable, so we have built a box for cleaner installation that the port natively can support 25 gig and 10 gig or even 1 gig. And the other application for this is for some of the data center connection when we build spine and leaf. Sometimes the leaf could have a top of the rack type of switches, or sometimes they might downlink directly into the server farm with the 10 gig connection. So these also make it easier and cleaner without using the breakout cable. Just a kind of side note to share with the audience, when you break out a 100 gig into 10 gig, because the way how the SerDiff, the serial is designed, the 100 gig usually only break down into 4 times 10 gig, not 10 times 10 gig. So we lose some of the SerDiff from efficiency. So this design actually contribute back to the efficiency perspective to make the installation cleaner as well. So that is another thing. All right, so last thing we like to share is the same block diagram, but now this one is with the different file to provide the output on the 25 gig, 10 gig, and also can broken down into the 1 gig as well. The rest is the same from a timing module, a control plane for the NOS, and then the health check on the BMC AST processor. I do want to spend 30 seconds to comment on the control plane. We partner with a number of NOS partner. So when you work with telco, certain things are very important, like the PTP timing. When you work with the enterprise, certain things are very important, like the VXLAN, the VXLAN tunnel termination endpoint, things like that. So the NOS partner we work with running on our control plane actually make this box either more suitable for the enterprise data center versus on the carrier, but they are exactly the same silicon. So last 30 seconds to sum it up, we put a table together of the 3 boxes that we present today. They again all use the same merchant silicon with the exception on the middle one that we use 2 Kuruman 2C to preserve the non-blocking nature of the design up to 64 port. The whole takeaway from today is the same off-the-shelf design using the same merchant silicon, but with the different port density and then the different type of breakout and supporting the type of optic for different applications for residential, for enterprise offices aggregation, as well as the cell tower cellular aggregation. The timing on the bottom is exactly the same on all 3 boxes because we just basically cookie cut all the timing design into our hardware. Last but not the least, allow me to spend the last 15 seconds on the TCAM. You notice the TCAM on the 2 larger boxes with the 100 gig, we say no, but we make it yes on the 25 gig. And the concept is when you're trying to do traffic control for ACL, access control list and all that, the closer you are to your endpoint customer, that's where you apply your ACL, your access control list. So we are always safeguard the traffic from the ingress. So that's why the ingress on the 25 gig connection, we have TCAM support. Usually once you get into the core of the backbone, the access control list is not as relevant because you kind of safeguard this right at the front door of your entrance. So thank you, everyone. We are seeking for OCP Inspire today with the free platform, and our marketing team, Will Chen, on the call with me this evening from Taiwan, and he will upload the rest of the spec and all these other. So with that, I'll stop here, and then if any question I can answer. Exactly 30 minutes. If not, I'll turn this back to the host.
Do you
Is there
consider this?
any software component of this?
I'm sorry, the audio cut off. Can you repeat your question, please?
Well, I'm just wondering, is there any kind of supporting software component of this contribution?
Yes, yes, yes. This is a disaggregated model. So the native of the network operating system came from our software partner. The box itself came with the diagnostic software. So the box boot up, kind of like a boot RAM kind of concept. So it has the diagnostic software. The box can boot up. We can do all the basic inspection of the box and things in that nature. But not from a routing switching perspective. That came from the network operating system. Our box came up to pass through traffic mainly from a health check and also benchmarking type of activities.
Thanks.
Thank you. If no further question, I'll turn this back to the host. And so I do want to be
I'm sorry,
respectful for the next. Yeah.
I have a question.
Yes, sir. Go ahead, please.
Craig, I think your audio muted.
Myself, I'm sorry. Okay, is that better?
Yes,
I'm
I can
sorry.
hear you.
So, is this related to the AT&T DDC3 effort?
No, that is not related to the AT&T DDCV3. This is on the aggregation. Allow me to use a picture to answer your question. So if you kind of look at a network like this, right, we are homing all the access traffic into the aggregation layer before we even hit the central office. The DDC v3 is on the core here, which will be a separate presentation. Sufukuma on the call, and I will be working on it at a later schedule.
Okay. Okay.
Yep.
All right. Thank you.
Great. Thank you. All right. So back to the host.
Yeah, thank you. This was good. Great presentation. I guess the next step is for us to get back to you, right, on your seeking. Would it be possible for you to send a response to John's earlier questions about the gaps you have with respect to the OCP inspired status and what the plan is for that? If you could
You're
send those
talking
over.
about the redfish,
Yeah.
okay, got it. Okay. I'm
I mean,
sorry.
it would be good to. Mhm. Yeah, go ahead.
Yeah, who asked the question? Who should I send it
I
to?
think
I wasn't looking.
John Leong had asked that question.
Oh, okay, got it. Okay, great. Thank you.
Anything
Well,
else,
you can
Lauren and
coordinate
Craig?
that with, you can coordinate that information with both of the project leads, Ripon and Lauren, and also, you know, you could include Rob on those.
Yeah, sounds good, John. Since we've
Give you
been
some
working,
direction.
Yeah, this is Lauren. I think I have one more question. So the specifications you're putting in, I know, you know, if you go look at our contribution page, we talk about a base spec, design spec, and a product spec, and kind of a combined spec. And on your second to last page, it's a little bit confusing which type of spec you're actually submitting for these products. So do you consider this to be a design spec or a product spec or
this is a design spec. Design spec.
Design spec, and you don't consider
design specs?
Go ahead.
Oh, I was just going to say design specs don't get OCP inspired, OCP approved.
Yeah, I think
Only
this is
products do.
actually, I think this is actually using the monolithic. It incorporates the base design and product spec.
Yeah, and then for if it is really that, then I think there's a requirement that the products are going to be available in the market sometime within a certain
Yeah, I
time
think
frame.
there's a 120-day requirement or something. And like I said, I think Rob is probably in the best position. I think he's been working on that. So we'll take that offline, but we'll definitely sync up to ensure
Yeah,
that
I think that's
those
one of the
requirements are met.
Yeah, that sounds good. Thanks for the clarification on that. Okay, we will circle back internally with Ribbon, if it's okay, since we've been working with you, and so
Yeah,
we just go
please.
to you as a
Yeah.
focal point of contact. Okay, great. Thank you, gentlemen.
Thank you for the presentation. Great presentation. Thank you for the comments. All right, Lauren, are you up for your piece of the agenda?
Yeah, I am up for it. If you can let me see.
Let me see if you are able to present. Let's see. You should be able to present, right?
Yeah.
And Lauren, you should be an organizer, so you could make yourself a presenter.
Yeah, I think I tried to log in, but I forgot my password and stuff to get logged in as all that. So I need to fix some logistics.
Yeah, I think you're a presenter now, according to my.
Yep.
Yeah, there it is.
You know the right file.
See it.
Yeah. Nice green slide with a hurricane or tornado
Something.
track.
Yeah.
Okay. Good. All right.
So I wanted to bring to the forum here, you know, a very specific use case that's been happening over the last 2 or 3 years with Princess Cruise Lines. And this is about their ocean network, which is basically a worldwide network that supports their ships out on the sea with various and assorted services. I have tried to contact, you know, Princess Cruises directly to try and get one of their technical people to come to OCP and give a presentation on this directly, but haven't succeeded in that, but I thought the information was interesting enough that I put it together myself from many public sources and press releases and other analysis that I saw online. So I'm going to go through these elements: design intent, elements of design, the network topology, and then basically on the ship, in the skies, on the land, and then some summation to complete the presentation. So the design intent. So this was done by a person named John Paget, who used to be a technical lead at Princess Cruises. He's now president of Princess Cruise Lines, and he was actually previously with Disney in terms of doing their Magic Kingdom kind of personalization. And so the theme here is personalization.
Did we lose?
Personalization and simplicity of the vacation experience. Getting a weird message here.
I can hear you.
Okay, can you see the slide still?
I can see the slide in between. Your voice was cutting off, so I was not sure if it was my connection or
No,
something
you're
else.
fine. So core strategy is to increase the personalization and simplicity of the vacation experience for every single person. And basically it comes down to anything on that ship, any service you want, anytime you want it, anywhere you want it, it's on demand. And the interesting premise here is that the platform is geared to reinvest information generated in real time back to the guest experience. And this is kind of a different kind of AI. It's not, big model AI, et cetera, et cetera. It's kind of real time AI in terms of feedback loop for learning about your customers on the ship and giving them a better experience over time. Fully connected edge computer infrastructure, cloud infrastructure, real time. It's a big challenge, and it may look simple, but it was complex from their point of view. Gosh, geez. So the elements of design includes all of these sorts of things: IoT wearables, IoT sensors, mobile apps, clearly tied to your personal phone.
Hey, Lauren, the slide didn't update if you sent an update. Oh, we still see the design intent.
Yeah, okay, so I am in a weird state here where I've got a thing saying screen sharing is now paused because something's not right. Just a sec.
Are you using Starlink or something like that? Any satellites? We lost the
Lost
screen.
Lauren, right? He should be back. I saw he just dropped.
Okay. Yeah, let's give him a couple of minutes. It's an interesting area. I don't know if we have any modules with satellite designs in the specifications. Let's see, coming back.
Are you back, Lauren?
Sorry about that, guys. I'm having some real technical difficulties here, and I don't know how to fix it. Can you hear me?
Yes, we hear
Yes.
you now.
Yeah.
Do you see the button to present, Lauren?
I am presenting, but I've got this weird message saying that screen sharing is now paused because I've got another window on top of something. So
Did you send that deck out before?
I sent it a couple months ago.
Oh, okay, let me see if I find it. But you can continue. We can see your elements of design now. IoT wearables slide is showing.
Yes, we do see the updated slide now, but it's not in presentation mode.
How about now?
Well, it looks like it went into present. There it is. Yes.
Okay, looks like I'm back. Okay, sorry about that. I'm not sure what's going on. So anyway, there's these are the set of elements of the design. So it goes from IoT wearables, IoT sensors, mobile apps, satellites, shipborne edge servers, cloud services, and then SDN and AI. So the actual network is powered by a company in Europe called SES. They provide the satellite services that connect ships with the terrestrial services. And they specifically have a service called Cruise Mpowered, which I'll talk about later. But right now I'm going to go through the different aspects of this at the different locations. So on the ship, in the skies, and on the land. So on the ship, there's these elements: the cruise ship, adaptive traffic management, and then obviously the satellite terminals that are aboard each ship. First thing on the ship is these ocean medallions. So this is a wearable IoT device. And it's really interesting because the device itself is passive, it's waterproof, it's personalized, it's got minimal information, it's encrypted, and it's actually got your name laser etched on it, so it's you know it's yours. So it's very secure. It provides identity and location services for mobile service delivery, which is a service called Open Now. Provides identity for fixed service locations, like bars and guest services. It's also used to identify you for embarkation and disembarkation at all the ports. So it's extremely, makes the experience really easy getting on and off the ship. And then there's other usage that's because you have this device, you can do things like find family and friends on the ship. There's interactive gaming and wagering. And then mobile streaming TV that's tied to your where you are, your personal presence. Inside the device is two microscopic antennas. So one's for near field communication, NFC, one for Bluetooth low energy transmission. Security, two-factor authentication. Basically, you know, possession of the personalization ocean medallion ID, and then at various kind of sort of positions around the ship, the crew verifies that your ID and a picture of you is associated at the service locations. So for instance, if you walk up to a bar, because you're wearing the device, the bar manager can bring up who's local on his PC or his tablet, and make a connection between the fact that you're there and who you are, and confirm that your ID is tied to your photo. On the ship, just to be, you know, understand what it took to do this. There's 7,000 sensors, 75 miles of cable, 650 readers, 500 edge computing devices, and 4,000 interactive portals that allow the ship to know where you are and who you are and be ready to serve. The satellites, Medallion Net, the satellite terminals, Wi-Fi access, switching routing, and some adaptive traffic management for various locations around the world, being able to adapt to wherever the ship is. In the skies, this is the SES network. There's two parts to this. One is a geo satellite network, which is a geosynchronous network. Those satellites tend to be very far out in space from the Earth. And then O3B mPOWER is a mid-level network that's closer to the Earth and allows actually shorter, round-trip transit times, which we'll talk about in a second. Here you can see kind of the SES satellite network specification standards. The SLA is tens of megabits to a multi-gigabit, 150 millisecond round trip, which, as you can imagine, is one of the key factors in terms of how you figure out how to split applications between, edge and cloud compute surfaces. You can see the standards there, other information, which I won't go through in detail. It's there for reference. The MEO altitude is 8,000 kilometers above the Earth, and it basically covers the midsection of the Earth here. So you can kind of see the coverage that the satellite has from a geographic point of view. Basically, everything except for the real northern parts of the continents. On the ground, internet connectivity includes the satellite gateways, platform, and then the terrestrial network. Satellite base stations are, operated with SDN, and those stations are actually located to a couple of popular cloud operators. So I assume they have one up in Seattle someplace for connection with Microsoft Azure, and they probably have some related to paths, for getting to Facebook and Google in the Bay Area. The pathways are dynamically allocated for forward and return path throughput. And it's AI enabled. So this is a real-time learning paradigm, not big data analytics. And for each passenger, they basically create a personalized genome that's tied to, your individual preferences. Information I got from this is that they, incorporate some pre-arrival preferences, that the genome model actually evolves 3 times a second. The algorithm adjusts based upon physical and digital interactions. And its location patterns, service preferences, and they inform the staff and they allow the overall shipboard operations to be optimized. So one of the most interesting things that I've learned about this is that not only is it important to know where you are to provide service, it's also important to know where you're not. So one of the things they do is they know when you're not in your stateroom, and they can predict the patterns of when you're there and when you're not, and basically end up, coming to service your cabin when they know you're not there or when they suspect you're not there. It's very efficient for them on board. So that was the last of my slides as a quick review, and just wanted to present that as an interesting, real world application of IoT, edge compute, cloud services with a big 150 millisecond, round trip time in between the middle of the network. Anyway, thank you for your time, and any questions?
Nice presentation, Lauren.
Thank you.
But this is definitely a big area, right? I think we have seen with, like your point about SES, O3 as the incumbents, but also new entrants, right? Like I don't know, Starlink might have a service, probably, Amazon's Project Kuiper has service. So what do you think are some things that we want to do here, Lauren? Do you think that we want to start a track of, how do you modify open networking for satellite communication? Because, there are different aspects of it that need to be looked
Yeah.
at.
So let me give you some. So this
Thoughts?
was kind of my first attempt at looking at
Yeah.
this from a broader perspective. This is one interesting avenue involving satellite coverage and what it means to build networks across that venue. And obviously, from a telco perspective, even though you're using satellite stuff, you have on ramps and off ramps into that satellite network. We might also want to take note that there's an additional effort going on that's kind of opposite of this, right? So there's a group that just started last year called ION, and they're trying to set up a situation where they can uh, create all optical connection points to any 2 points around the world and basically bypass the existing switch-based internet that we have. And so
Do
that's
they do like do they do like any kind of caching or like a CDN kind of thing? Like I could kind of see like it would be interesting to like maybe cache Netflix or something, if
actually
kind
they're actually looking at doing all optical, basically on-demand circuit-based networks that or go across multiple providers. So like you could think of a situation where you have, um, like two hospitals located different places around the world that want to do interactive surgery or something like that. And they want to create a completely optical path between those 2 points on demand, basically bypassing the existing internet. And that's what this group is trying to do. So they're coming up with a whole model of distributed computing where they optimize the links real time.
like a mesh network kind of a thing.
Yeah, mesh network or completely optical. So now they're actually not converting the signals to to Ethernet packets in a
Yeah, so
electrical
Lauren, you're
sense.
talking about a completely different use case other than satellite communication, right? You're talking
Yeah,
about a different
it's
work
actually the
stream.
opposite of it, right?
Correct,
The
correct,
satellite
correct. I
network,
get your point. Yes, exactly.
the satellite network is worldwide. It's available.
Correct.
Got a certain set of characteristics. One of which
Yeah,
is long latency, right? Or
yeah,
long latency. But these other guys are doing the opposite. They're trying to figure out how to
yes,
do
yeah,
completely low latency with all optical connections between any 2 points in the world.
exactly.
Um, and so
I've seen some of
that's kind of
that.
yeah.
Yeah, and I've seen some of that implementation on your second use case by energy companies that own the
On the
power
on the
lines.
fiber. Yeah,
Yeah, and then they own the line. So then like to your point, I'd seen in Canada, this is about 5, 10 years back, I think.
yeah,
They were connecting hospitals to your point, specifically for a special service,
yep.
lease line like service, but optical, right? To your
Lease
point.
line, but optical. Yep.
Yeah, yeah,
This is
yeah.
a more dynamic effort to
Correct.
do that worldwide. But it's
We
kind of
should
two sides of the coin,
investigate.
right? So it's
Yeah,
taking our current telco transport network, which is all internet that's all switch based. And the point they make is,
yeah,
yeah, the optical connections are disaggregated, right? You go from optical connection, you go to a electrical switch, then to another optical connection, to another electrical switch. In some sense, they've got a point that it's burns a lot
yeah,
of power and a lot of conversions.
yeah,
So
yeah,
so I just wanted to point that out that the whole networking part of OCP, telco, data, it's all based on
yeah.
switching technology at this point. But there's these things of how you actually create real worldwide networks that have certain attributes where there's efforts afoot that are different than what we're typically used to talking about in
Yeah. And I
OCP.
think the co-packaged optics in the data center is also trying to do the same thing. They're trying to intersect, right? Get out of
Yeah,
transceivers, SFPs. Okay, so good. I think the good point is that we should offline figure out these two tracks, like you said, right? One is a satellite track. If there is some thought leadership we can bring in, right, to your point, from either the existing incumbents or from the new generation problem solvers, right?
Yep.
SpaceX, Kuiper. On the other track, like you said, is the other side is the underlay side of it, which is becoming optical, and what does it mean to designs and specifications. So I think those two definitely are good topics to investigate.
Yes.
Okay,
All right.
cool. Anything else from anybody else they want to share? I know we are running out of time. Okay, so if there's not, I know there's one topic that Shiva and had requested for DDC, so we'll try to find a new time slot for that, Shiva, for next time. Okay, and
Okay.
we'll send them out.
Okay.
And if there's any other topics, please let us know, and then we will schedule those. And hope to connect with you all soon. Have a good day.
Great. Thank you all.
Thanks,
All right,
everyone.
cheers.
Thank you.
Thank you. Bye.